Hi everybody. To answer this, you will need to first understand the formula for Laplace or the definition for Laplace. What is the definition for Laplace? So let me just write it here so that you can see what we're talking about. So when you've been taught to define Laplace, we say Laplace will be equal to limit as a approaches infinity, integral from 0 to a e power negative s t multiplied by the function. Okay, that's the function we have with respect t. So this is the formula that we basically need to know. Okay, so this same formula can be related as 0 to infinity. When you put this infinity where a is, this limit will disappear. You remain with something like this right here. So this is the formula or the definition for Laplace. If you don't know this, you can't answer this exam question. Okay, so now let's now try to answer this. So we'll say the integral from 0 to infinity, okay, from 0 to infinity of e power s or power negative s t and a dot. This dot means multiplication, okay, times. Where f over t is, we'll put something like this. Okay, so you see what I've done here. I've put this, but the question has got x here. So there's no problem if you switch. You put x here and here. So this is what we have. And we respect now what? Dx, not dt. So this and this, it's just the same, okay? We have put this e power negative st. So on t we are putting x because the function has got x right here. Okay, so now we can work out this. Once we manage to integrate this one, that means we found the answer. Okay, so we can now write it properly so that the integration is done properly. So the laws of indices here, we add the powers, okay, and then we say dx. When the bases are the same, what do you do to the powers? You add them, okay? So I've added. I'm now getting the same thing. I'm getting the same thing right here. What do I need to do now? Here, I can factor out what is common. X is found here and here, so it can come out. So it will look like this. Actually, when factoring out here, remember to also factor out the negative. So negative must come outside. Also x outside the bracket. So what are we going to remain with here? We'll remain with s. This negative is outside and x is also outside. So here, since there is positive and we have factored out negative, here we also have a negative and a 2 right there. We say dx. So now we are ready to integrate. We are ready to now do what? Integrate. So now, before we do the integration here, we need to understand something, okay? So what is it that we need to understand? Let me use red marker here. So we need to know that when you have been given something like this, okay, to integrate this with respect to x. Let me do this properly so that you people can see and understand what I'm talking about. So when they say integrate this, the answer here, okay, will just be what we have here. Let me put a negative here so that it looks a little bit similar to what we have. So we are respecting x, so the answer would be negative e, okay, or e power negative 3x. You just copy what you have, and then you say divide by negative 3. So you just, when integrating this, just copy the way it looks. You copy the way it looks here. Now, you focus on what is here, excluding the letter. So divide by that. You are done. Of which our answer can be like this. Negative e power negative 3x over a 3. Just like that. Okay? This is our answer. So now, using this idea right here, we can't face difficulty to integrate this. So we just say, okay, it's equal to what we are able to see right here. So that is the e power x s minus 2 inside the brackets. This is what we are able to see. So now divide by a negative and this. That's what I said. Okay? Leave the x. That's what I just said. Okay? So now, once you do this, don't forget the limits. We have lower limit, a 0, and upper limit, infinite. Okay? Now, from here, we can write our work properly. Start with a negative, and we have 1 over s minus 2. Okay? This negative is straight with the bar. Okay? If it was straight with what is down here, I would have applied the brackets like it is here. Okay? Now it's easy. Straight with the bar. I can't put the brackets. So everything here multiplied by e, I've just separated what is here. So this and this are the same. Okay? Let me put the limits. We have something like this. Okay? So now, here, our duty now is to apply the limits. So let me put it somewhere here so that you guys can see what is going on. So we have negative 1 over s minus 2 multiplied by e power negative x s minus 2 right here. So this is what we basically have. I've just copied what is down here because I've run out of space. Okay, so now here, let's apply the limits. So these limits will be put where x is. We have negative 1, okay, like that. And here I can put the brackets so that I apply the limits nicely. So if I put infinity where x is, all this power will just be negative infinity. If I put here, so when we get this infinity, put it where x is, it will be multiplied by whatever is here. This will just be power negative infinity. Minus, okay, the lower limit, which is a 0. If we put a 0 here, we'll just have a power 0. Everything here will just be power 0. So thereafter, we can say negative 1 right there, like that. Here, we have a 0 minus a 1. Okay? Negative infinity. Okay? E to the power negative infinity. The answer will be equal to what? To 0. Okay? Because this negative infinity is approaching the 0. So the answer will always be a 0. And then e to the power 0, the answer will always be a 1. Such that when you multiply, we have these brackets, negative 1 over s minus 2 multiplied by 0. It will just give us a 0. Negative and negative, it's positive. 1 over s minus 2 multiplied by 1, the answer will be 1 over s minus 2. This is our answer. So this is how you deal with the Laplace transform. Kindly subscribe to my YouTube channel. If you have enjoyed this video, like it, share, and comment. Thank you so much.